know I won't be catching feelings. But she got me catching feelings. I can't be catching feelings. But she got me catching feelings.
Hey guys, what's up? It's your boy Trix. Today we're going to be doing another Rust Rogue video. Today is Bloodstains, and then next week we're going to be doing another video. Also, I just wanted to say for the this is kind of related to the Spring stuff and Java roadmap stuff. I found, I think this is the website. There we are. So in this website, it has a Java roadmap, right? So on this Java roadmap, my dark mode is conflicting with this, I think, maybe just a little bit. Anyway, so it has Spring here, right? And it links to some tutorials and stuff, which I'm basically doing already. But it has some tutorials that like I haven't seen. So this is like the Java Guides one, Beldong, YouTube, then some more YouTube channels. Obviously, I'm just gonna try using like the official ones just because I think those will be more useful. Of course, like you can do a course from Beldong and stuff like that, which will be a lot more helpful, but Beldong's courses cost money. I'm cheap. But yeah, eventually I might do them if I have time, but I'm just planning to like get the basics down, understand them, and then move on. So I'll do Spring Boot, which are basically the same thing, and then Play, and then Spark, and then I'll move on to ORMs, JPA, Spring Data JPA, Hibernate, eBean, JDBC, and then I'll keep moving, and then I'll eventually go onto this backend roadmap where I will, when this loads, do this stuff. Learn the language. That doesn't take you anywhere. Fair enough. Where it will just take you through. What's this? Ooh, there's another one. Nice. But yeah, I'm just planning to go through these roadmaps to like get better, honestly. Then it will take you to DevOps. Interesting. But yeah, we'll see how we go. There is one for Rust, but I don't believe I know enough Rust yet to attempt a developer roadmap. I could do it with Java just because I have the most experience for like Java and Flutter. Where's Flutter? Flutter's here. Flutter does basic start, set up development environment, widgets, IDs, fonts, images, other data sources, working with assets, that's fine. VCS, repos, design principles, those are fine. Package manager, that's fine. Working with APIs, WebSockets is okay, RESTful APIs is okay, GraphQL, haven't touched it yet. JSON serialize, deserialize is fine. Storage is fine, share preferences and is a pain though. Firebase and SQLite, bit harder to get started with. SQLite is like the easiest. Firebase is a little harder to get started with. Shared preferences is like, depending on the library you use, is pretty easy. I was using, I think it was Hive, and Hive made it like, the performance of Hive is really fast, but just getting up and running with it is a little difficult. I say a little difficult. It's more difficult than using something like SQLite, but less difficult. I think it's a little more difficult than when I was using Firebase. Yeah. These are alright, and these aren't that hard. That's not that bad. Then state management, I would recommend Provider, or I would recommend Provider if you like want an easier time. Block if you're working with other people and you want to like manage things, and these are like the ones that you would normally have if you are a JS developer. Animations, most of these aren't that bad. They're just like if you want to animate a widget. They make it fun and more customizable, but you don't need to really touch this unless you want those features. Testing, unit testing is easy. Widget testing is pretty easy as well because most of the things that you have are a widget anyway, and the syntax is very similar to unit testing. I haven't touched integration testing yet, so could do this roadmap afterwards. RxDart, never done before. DevTools, Inspector, Outline, Memory Allocation, never used any of these. Parsing, Code Manager, Bitwise, GitHub Actions, Firebase App List. I use the Firebase one. I've done like bits and bobs of each roadmap, and it's just like, ooh, interesting. I've done this stuff. I haven't done this stuff. Like I've done Firebase Analytics. I've done deploying to the App Store, the Google App Store. Oh, that's the Play Store, isn't it? The App Store is for Apple. I've done Play Store. I haven't done App Store because I don't have an iPhone. But yeah, that's fine. And then you just keep learning. So I would say I've nearly done the whole of this, except for GraphQL. I've done Provider. I've done a little bit of Block, but I didn't really like it. I haven't touched this Java, this like JS side of state management, just because I didn't enjoy. I didn't really have projects that required it that much. Like you could pass around parameters when you need to use them, and then if you do ever like want to share something between lots of pages, state management is the way to go, just so you don't have to keep passing things between everything. To explain state management, it's basically like if you want multiple pages to have access to the same thing, you'd use state management. So like say for example you're logged in or something, and you need to pass around that authentication and you need to pass around that authentication token whenever you're on a different screen, instead of having to redo the authentication every time you're calling that API with your user details and stuff. You would just, when you log in, have all of your state linked. Like you'd have the top level state being that login page, and then all of the state that's required for authentication would sit under that, where it's like a stream where that authentication can be passed down to every page underneath it. So you could just access it without having to do all of these calls again. You still need to have all of those calls to request data again, but you won't have to pass around that authentication token that you've been using to log in, or like pass around user details to request something. It would always be that you have that data already accessible to you, so you don't have to carry it everywhere. That's what state management lets you do. Like that's one use case that I used it for. You can also use it for like checking internet connectivity. If you want to, it basically like if you want to share something between multiple pages without having to pass things around. The only like downside of state management is it's very difficult. It's not impossible, but it's very difficult to send state up the stack instead of sending it down. So imagine it like one of the videos I watched was from, I think it's the Flutter Hero. I've forgotten his name. I watched one of his tutorials when I was doing block, and he explained it very nicely, where you can send state downwards, and sending state downwards is very easy. That's what most people use it for. But when you need to send state up, like you're modifying state and then you need that to persist everywhere else, it's a lot more difficult, because state management is mainly used for raising state, taking state from one place and letting you use it somewhere else, right? I mean, for sending state downstream. Sending state upstream is a lot more difficult, because normally you wouldn't modify state when it's sent down. You would just use that state to do something else with it, right? When you need to modify that state, you need to raise that state up a level and continue to raise it, and if for whatever you need to use it, right? So imagine you're like 15 widgets down, and you wanna use it in the top level widget where that state was first generated, right? You need to raise that state until that top level widget, all the way from the bottom level widget, which makes it a little more difficult, which is why you would have something like getX, or I think it's getX, where you can literally, if you want to like update state somewhere and you're in another widget, you could just do get and then the name of that state variable, and you'll literally just pull it from wherever it's currently being used. But I'd say if you want to check it out. I recommend, if there's a particular language that is on here that you are quite familiar with, I'd say start with that. The computer science one I haven't even looked at. What's the computer science one though? Mm-hmm. Ooh, interesting. Yeah. Interesting. Okay. That's fine. That's fine. That's fine. That's fine. Front end or back end. Okay. Yeah, of course. Everybody's either going to be a front end or back end engineer. Like, come on. And sorry, what I mean is like I find it very on brand that the computer science one literally says if you've done all of these things, go either front end or back end. It doesn't tell you to like choose a language or something. Whereas if you do like a language specific one, it's going to be like, okay, cool, now go to this part of this diagram. Like I'm guessing with TypeScript, it's going to tell you to continue on with the front end one, front end or back end. Yeah. Java just defaults to back end, which is actually kind of nice. Anyway, Python one, I know some people that like Python. I don't particularly like it, but it's like I don't like interpreted languages, to be fair. Starting off with like, okay, this completely fine. Data structures completely fine. Advanced topics, and you got regex. That's fair. This is fair. This is just gonna say I don't know anybody who uses PyPy, pip, and conda. Conda if you're using like what's it called, data science, and then pip if you're just using things like installing things normally. I don't know anybody who uses PyPy, but okay, that's fine. This though in advanced topics fair, but have this way further down. Regex is yeah cool. Regex is just like a what's it called, a filtering language, right? But regex is very hard to get your head around if you haven't like used grep or something before. Like if I do this live grep is using regex, so like you could do whole regex search patterns. Like if I want to exclude Rust, takes out everyone that has Rust, right? Or exclude .rs, right? But if I just do .rs, it will show up. But I'm just saying, oh, I want to exclude every .rs. Nothing's gonna search up. That's one like regex pattern that you can use. That's the first one that came to mind for some reason. But regex is like very hard to get around. Like most people wouldn't think about that. Like for normal computer science, or like normal languages, it'll be like, oh, you don't want to include something, do the not equal to sign, like, right, which will still give you nothing, but that's because you're doing this, right? It like anyway, that's just my little rant. But I'd say regex is a lot harder than most of the things here. Django is nice. Flask is okay. They have fast API in between both. Okay, that's fair enough. I was gonna say like I've seen lots of people use fast API for Python just because it's a lot lightweight than Django, but it's a little bit more handholdy than Flask, which is why lots of people recommend it. But it's good to see that it's there. I'm hoping PyUnit is a lot like JUnit, but anyway. I'm glad that it has like these recommendations for if you want to go backend or DevOps. I want to give this a star on GitHub actually. I like what they're doing. It was updated 4 days ago. Yep, I like what they're doing. They also have a .NET one if you like C#, Kubernetes if you want to go into DevOps E-type stuff, blockchain if you like blockchain, DBA if you're doing databases. Wait, hang on. Yeah, I think it's databases. Design systems if you want to do like system architecture, Spring Boot, and Java obviously if you like Java. Go if you like Go. I'm not going to downplay how much I dislike, sorry, Go and Python, but if you like them, there's resources here for you. There's Flutter, Android, GraphQL. I'm guessing the Android one is going to be in Kotlin. I would be surprised if it wasn't. Yeah, Does it have a key for why Java's blanked out? Or has this not been updated? Okay, it at least explains it. I was gonna say, because Java used to be the standard for Android apps, but they moved to Kotlin after a while. So you find it weird that Java's still there, but it's fair that they're saying that you could use either. You can make Android apps with Java. It's just that Kotlin's a lot nicer syntactically. Functionally, they are basically the same. If you know, this is going to be a bold statement coming from me, but if you know Java, I want to say you could hack away at Kotlin, Flutter, and C#. You could, because I've touched all of them. I touched all three as well, and C# is like, some of the libraries are similar, some of them aren't, but C#'s a lot. Flutter, like Dart, which is the language that Flutter uses under the hood, Kotlin and C# are just nicer implementations of how Java does things. So everything you can do in those three languages just make things a lot easier than what Java does. You can do everything Java does in those three languages. It's just those three languages have things that are like unique to those languages, right? So like in C# and Flutter, C# and Dart, sorry, I want to say they're most similar with how they're syntactically written. It's just that C# exclusively has a link queue. Between Kotlin and Flutter, Kotlin is like the least boilerplate heavy language like Java, I want to say. Kotlin syntax is a lot similar to like Rust syntax, I want to say. Rust or like Go syntax. Hang on, let me open up a Rust file. I want to say that Kotlin syntax is very similar to Go syntax, but easier than C# syntax. And then Flutter is kind of like, if you just want to code in Java to make an app, like pure Java, Flutter is basically one-to-one feature parity to Java. Everything's basically the same. I can just show off an app actually. CD. I don't know if my app is here. Oh. There we are. This is a Flutter application, and if I just scroll through it a bit, you have a main function, which is normally inside of a class. Just Flutter makes it that you can specify one outside of a class. Then you're saying you want to run something, which is an app, which just executes this file, right? So, where is my app? My app is not this. Why do I have my homepage? Oh, I think I forgot to delete my homepage, that's why. Anyway. C into SSC. Yeah. I just forgot to delete my homepage. Lol. Anyway, this is app. This just runs my homepage, which goes into screens, exports, and grabs my homepage. I could probably just like delete the nonsense inside of that main.dart, which isn't necessary because it's not necessary, sorry. But everything like syntactically, I want to say, is very similar between Flutter and Java, just because the languages look basically the same. The one that looks like the most different out of both of them, I want to say, is Kotlin, just because like I don't even know if I have a. Oh yeah, I do. I don't know how many of you guys who are like watching my Rush streams also watch my spring streams, but I done I think it's spring SSO. Hang on, no, it's blog. There we are. If I see into SRC, main Kotlin com example blog. There we are. I'm gonna do blog application. That's what it looks like in Kotlin. So Kotlin still has classes. It's less boilerplate heavy, if that makes sense. You don't have as many curly braces, so depending on like if you have multiple classes in the same file, it could be kind of difficult knowing what's part of what and like where one class ends and one class finishes. I do believe you can specify the extra curly braces and it will do it for you, but like argument assignment, I mean variable assignment and variable declaration is a lot nicer in Kotlin, I do want to say. Like if I cat say entities, yeah, that's a lot nicer. Where you could just specify var for everything. Sometimes in Java you can't specify var for everything, and you actually have to do an assignment. But well, this is like a record in Java, right? But it is nice. Anyway, let's just get back to Rust Rogue. That's my little like thing about yeah, these are the language parity things that I found. And I've been speaking for 22 minutes and haven't started coding at all. I am so sorry. Sorry about that, guys. I got sidetracked. Anyway, check this out. Future Cameron might be lazy and not link this in the description. So if I haven't linked it in the description, it is called roadmap.sh. Check it out. I think it's pretty neat. There are a ton of tracks that you could look at, and you don't have to do one that I'm recommending. You can do whichever one you want. They're adding new stuff all the time. I have no affiliation with this website or anything like that. I just, as you saw, I literally just started the thing. If I had an affiliation, it will show up in that I could contribute or something. That was one of the contributors or something like that. But I have no connection to this at all. Actually, if I click on security, no. Yeah, you can see if I click here, I don't have the settings option, so I don't have any like auth privileges on this repo. So I have no actual like connection to this repo. I'm just shilling this repo because I think it's pretty good. Actually, because I've done that, I'm going to go to my stars and remove the roadmap ones that I currently have. So this awesome roadmaps and this Java developer one I will remove because they are already on that developer roadmap one. And I wholeheartedly recommend it if you just want to learn something, or you're just interested in what other people think are not what other people think are, what other people think is crucial when you're like looking in industry for a position. Check out this website. It's just a bunch of people who have like come to an agreement that these are the things that people should focus on, or like people in the field are currently working on. In terms of Java, I would say, looking at it, besides this web frameworks one, ORM and JDBC, I would agree. Just because for what I'm currently doing, we don't use them. Instead of web frameworks, for me, for my current job, it would be, I would replace this with HTTP frameworks, just because these have a kind of a bit of bloat. And then instead of ORM, it would be, I think it would be in the backend part, wouldn't it? Let me just see if it is. No. They're missing some from here. They're missing some from here. They're missing some from here. Is it in DevOps? I'll be surprised if it is. Interesting. Well, for DevOps, you can use any language you want, right? Just to explain that, with DevOps, you can use whatever language you want because all you're doing is deploying something to something. Like you're deploying or like making sure that you can execute a script to do something. So as long as you're doing the right commands or you're programming it the right way, you can use whatever language you want. There might be some like unique thing about one library is like unique to one language. Like in Python, that happens a lot where you'll just have a library that is unique to that service that you're using that you need to use, otherwise you can't authenticate. But most of the time you can just like wrap that library with the language you're currently using and just make calls to that library with the language you're programming in, and it'll be fine. There might be a little bit of overhead just because you're making a call and then having to like translate it back to translate it and then send that translation back up, but it should be fine. Most of the time you just do that with shell scripts though. Some of the stuff does overlap though. That's what I was looking for. So literally I'd have to do all of Java, then all of backend, then all of DevOps. Nice. Anyway. I just find it very interesting. But yeah, I do recommend this. Also very weird that they haven't like updated this with the Spring Boot one, because there is a Spring Boot roadmap, unless the Spring Boot roadmap is literally just copy paste of the Java roadmap. Is this literally just build on courses? Yeah. Nice. It's literally just like linking to a Beldon tutorial. If you haven't seen like Beldon stuff, basically if you search for anything like Java related, most of the time you'll just see something by Beldon. It's not like a bad thing. It's literally just that Beldon covers literally everything. Like if you ever like are wondering, oh, how does something work? Beldon's probably written something on it, and it will just be like top notch, like explanation, which you can just be like, cool, I understand it now. I think there was something that I was like, oh, there was like one thing that I didn't find, and I was just on Netty, and it was like I found it on some random blog from like 3 years ago. That was like, well, I'm saving this now. But it's sick. I recommend it highly. Yeah, I'd recommend this. I think it's pretty good. Yeah. Anyway, let's get cracking on. Took up a bunch of your time just from me chatting. Sorry about that, guys. Anyway, Bloodstains. Our character lives the life of a murderer. Looting and slaying at will, so it only makes sense that the pristine dungeon will start to resemble a carnal house, sorry. I have no idea how to say that word. It also gives us a bridge into the future chapter in which we'll start to add some particle and visual effects in ASCII CP437 to the game. Storing the blood. The tiles either have blood or they don't, so it makes sense to attach them to the map as a set. So at the top of map, the RS will include the new storage type hash set. Cool. So right here. Nice. In the map definition, we'll include a hash set of U-sites to represent tile indices types for blood. So that's gonna go right on the depth. U size. Oh yeah, I need the. There we are. Add in the map generator will initialize it. Let me just. There we are. Rendering the blood will indicate a bloodstain by changing a tile background to dark red. We don't want to be too in your face with the effect, and we don't want to hide the tile content, so that should be sufficient. We'll also not show blood that isn't in visual range to keep it understated. Oh, I'm guessing this might be like you could have bloodstains on the map randomly generate in the future, maybe. Just to be like, oh, if you go into a dungeon, there might be some entities that have died already. I don't know if you'll do that though. In map there is the render section now looks like this. Oh no. There we are. There we go. Blood for the blood god. Now we need to add blood to the scene. We'll mark a tile as bloody whenever someone takes damage in it. We'll adjust the damage system in damage system the RS to set the blood stain. Okay, so damage system. There we are. And let me just grab this. And then from here I'm going to what's 19 minus 6? 13. 13J. There we go. I should really turn on relative line numbers. Actually, I think it's N. No. Where is it? Total line number. No, I want relative line numbers. P. No. R. There we go. That's a lot better now. I hope that saves. Actually, I can test that. No, I didn't save. How do you turn around to line numbers? Mm-hmm. Why would you want to turn off relative line numbers? It's so easy to jump. Envy Chad. Let's take a look. I'm hoping it has it somewhere. Docs. Post. Custom config. Do I really have to? Relative, of course, relative. Is there a way to? Is T? No. W? No. U? T? R? N? Because then you could just do 48. You could do like, if you don't want to go to the top, where you do like G. I mean, GG. You could just do, oh, I want to go up 48. Or like, oh, you want to go all the way to the bottom, yeah? You want to go just to that pub, where pubs track random entry. You could just do 46 up. Right there. That's nice. I want that to persist though. How do I? I swear, if I do this and I do. Interesting. See? No. F. G. Ooh, can I put the Giplim up? Nice. I didn't know that. I've always just put up git blame in IntelliJ. I've never done it in Vim. That's nice though. For those wondering, git blame is very nice when it's like, I don't know when, because it will be like, oh, in IntelliJ, it will say, this is owned by that, like at the very top of the function, it'll say I wrote it, and I'll be like, I don't remember writing this. I'll click on it, and then it'll tell me how long ago I've written it, and then sometimes I'll be like, oh, I wrote this like 2 months ago. That's bad. I've done that with tests as well, where it's like, oh, I've been looking at tests, and I'm like, I don't remember writing this. I'll look at it, and then I'll look at the revisions, and it'll be like, oh yeah, I added it on this date, and I was like, why did I add this? And it'll be like, oh, we're using something called SonarLint, which basically tells you like if there's something wrong with your code, like maybe you should be adding more tests. Oh, when you're testing, try doing this instead. It gives you like helpful things to look out for. And it'll be like, oh, you done this equality when you could have done this. Like for some reason, I done a assertion to check if something's equal, but instead of checking like if x is equal to y, I done x equals y dot is true. And I was just sitting there thinking, what was going through my head why I thought that this was a good idea? Like, it's not a big thing, right? It's still doing the same thing, but it's just, it's not like I haven't used is equal to before either. And like syntactically, it's shorter to just write dot is equal to and then the thing that you're specifying than writing equals whatever variable name end bracket dot is true. Just Anyway. It's just small things like that that get me, that I'm like, I have a long way to go. I remember someone saying that the best programmers are like ones that try to do things as lazily as possible. Because it can be like you can over-engineer something and it might work for that moment. But it doesn't mean it's always going to work that way, right? It's probably going to want std iter map. No, it's not going to want iter map. It's going to want what the hell is it called? It's just in that damage list. Yeah, I know what I need to do. It is yeah, I need to do position as well. That'll probably be in components. Actually, I could just do position and I should just import. Yeah. Going back to me saying that, oh, don't over-engineer things. You can over-engineer something for that moment, but if you haven't given it enough thought to be that, oh, what if this happens in the future, or if that happens in the future, and building it for change, it doesn't mean anything, right? Because you're going to be constantly changing it to suit that purpose. Obviously, just hacking something in isn't good either. Try to think for, oh, if I put up all of this work in the beginning, my technical debt in the future will be a lot less, right? Because there's this book called The Philosophy of Software Design, which basically goes over something similar, right? Which talks about this stuff that's like, the main premise that I took away from the book, you might read it and think something differently, but the main premise that I took away from it was you can always design something, right? And that design will always be good, for your current purpose. But when someone else comes to you and they're like, oh, what about we want this feature, that feature, whatever, you always hear like, oh, this team has spent a ton of time trying to refactor or implement this new thing, and it just takes a long while, right? Because it's a new thing. But if you just plan for, okay, cool, they might ask us for this, that, or whatever, you may not always get it right. You may not know what they're going to ask for. But if you just code in a way that, okay, I'm coding, it might take longer up front, but because you're taking more time to think about, okay, this thing might change, that thing might change, I might want to do this in the future, I might want to do that in the future, oh, maybe we will get this ask, which might make us change this. It makes you think about, okay, cool, maybe it's not the best way to do this, let's try doing something else, because at the end of the day, you just want to reduce the amount you have to do in the future, right? Like the best way, and that just simplifies it to, I want to do as much work as I can now to make sure future me doesn't have to put that much effort in to change something, right? Like the other day, I was coding something where it touched, I think, like 60 files, and it wasn't supposed to be a big change, right? But it ended up being a big change just because the way that module was structured just touched a lot of files for that specific thing. And then now we have a thing to refactor it so that if we were to be asked it again, or to change something in that section again, it'll be a lot easier to do. Yeah, it might take a while to do it, and it might be a lot of upfront work to get it done. And we may not even like have to do something with that piece of it again for a little while. But because you're putting up that work upfront now, if someone were to use that or something, or another team were to come and wants to implement something or wants you to change something, or you're just asked something else, it'll be a lot easier to implement because you segmented everything out that only like certain things depend on certain things, right? It just makes things a bit easier. I really recommend that book. It's basically on system design, like saying things that will make things easier for you, like designing things twice, asking for alternative opinions on how things should be designed, thinking about technical debt while you're implementing things, writing unit tests as you're building instead of writing them at the very end. Because think about it, when you're unlike writing comments as you're building instead of writing them at the very end, how you should be commenting to not just regurgitate what's on the code, but why it's there, what's its purpose, and why it's working the way it is, instead of just, like lots of comments that I wrote in university were just like single line comments for every single line. That's like, oh, this line does this line does this. Obviously, you would know if you just read it. What someone would want to know is if they call that function, they want to know why does that function exist and what is its purpose for being there, right? Like, why is it segmented out? What logic does this unique function have that it needs to exist besides just reading the function name, right? Like, using variable names and function names that are self-documenting is good, but just because it's self-documenting doesn't explain why it's there or what its purpose is for. Sometimes it might be like what its purpose is for, but most of the time you just want an explanation of why that logic is there, or what does this logic do uniquely that it needs to exist. And I really recommend that book. I'm very grateful that my senior recommended that to me, actually. Because like early days when I was reading it, I was like, I understand some of this book, and I can understand using some of this book, but I feel like it's more of a reference book. But now that I'm touching more stuff, I'm like, oh, that's why this book talked about it. Oh, that's why it should be like this or that or whatever. I'm not going to like spoil the whole book just because I feel like it's a good read for anybody, but I do generally recommend it. It's called The Philosophy of Software Design, and actually I can show you on Amazon. I'm not sponsored, by the way. I have no sponsorships. I am unpaid for any of this that I'm saying. I'm just saying I think it's a good book. I think it's philosophy. I'm not sure if that's... No, I spelled that wrong. Philosophy, yeah. John Osterhaus. Yeah, I recommend this book. If you've read Clean Coders, it's kind of like that book, but I would prefer this to Clean Coders. In some aspects. In other aspects, Clean Coders is a little better if you're like getting into coding, or you haven't done coding before, just as like a, what's it called, best practices, right? Whereas this is, oh, if you've coded for a bit, it makes sense, and you don't think about it until like you actually read it and are like, oh yeah, that makes a ton of sense. Why haven't I been doing this before? Like in Clean Coders, there's one line that is referenced in this book actually, where it says function shouldn't be longer than 5 lines, right? Which makes sense because you want to make logic easier to read and more digestible for someone who comes to look at it, right? But I think I talked about this before as well. If you have a loop or something, most of the time your logic is going to go over 5 lines. And if you're using a language like Java, debugging is a pain when you're going through a ton of method calls. Like you'll have a function that's like 5 lines, and then let's imagine you have 2 method calls in that function, right? Which is reasonable if you have a normal function. If you have 2 method calls in a 5-line function, and you continue to only have 5-line functions, I don't even want to imagine what your stack trace is going to look like if you have an error, if something throws an exception, if you need to debug, you're going to be chucked between a ton of files just to find something, when something could be resolved by, okay, cool, this logic could just be one big function because this logic isn't going to be reused, right? Like, when I was at university, we weren't told to read Clean Coders. Instead, what we were recommended is if you have to reuse logic somewhere, then it makes sense to make it a function, right? But if the logic you're using changes something a little bit, don't put it into a different function because it's doing something different, right? Like, you could make it into a function that takes a parameter and does something with it, right? Fair enough. But if your logic is purely dependent on that, and some lines are similar, some lines are different, the logic is obviously different, right? There's no point in segmenting that into a different function. Yes, you can have lines that are repeated, and it's fine to put that into a separate function. But unless you're going to be repeating that logic, there's no point segmenting it out. Yeah, cool, you can... It also comes down to, do you think you're going to be using it again in the future? If you do think you are going to be reusing that logic in the future, you could segment out that logic. But until you need to, you're better off just keeping it in the same place, and then when it comes to it, your IDE should be able to tell you, okay, cool, I found this function here, I believe this logic is similar to this logic somewhere else. Think about if you need to refactor it into its own method call, so that you're saving on the number of lines you've written, or if it should be separate because the logic is different, right? Just stuff like that, because again, you might end up with like a massive function, but there's also a thing in that book which talks about what's it? Depth of a function, right? So you might have a very deep function, but you don't need to know about everything in that function. You could just know your knowledge of that function will be very abstract, and then you'll have these massive functions that have tons of parameters on them, which basically leak a bunch of business logic, which you just don't need to know about, right? Stuff like that. If you have a ton of variables in a function, when you don't need to know all that business logic when you're calling it, you probably don't need it, right? The whole point of functions is don't leak logic. And one of my seniors told me this as well. Try not to leak logic between different classes and methods and stuff, because you don't want something. You should always think about it as, you don't want something else to know about something if it doesn't have to, right? You might end up with a ton of functions that have lots of variable names, arguments on them, but it's not leaking a ton of stuff, right? Or maybe you just want to pass one argument that has some parameters on it, right? Like maybe you make a record that takes some arguments so that you're only passing one element around. That's fine. That makes it simple. You just need to remember that, oh, if someone else comes to this, they'll need to know that that argument has all of these parameters on it, right? So most of the time you'll just see a couple classes or like a couple methods with a ton of arguments on them, just because it's a lot easier to pass that around than making a new one, a new record or new class that takes all of these parameters just so you can pass it around. But yeah, that's just a little like design principles with me. But I do genuinely recommend this book. This one here. If you cannot afford it, it is quite cheap. If you cannot afford it though, I recommend the Kindle edition just because it's digital. You can read it on the Kindle app. If you can't do that, I'm pretty sure you could potentially email John Osterhaus and see if they are willing to send you a digital copy for free. I know some authors do that. I'm not sure about this author specifically, but I do know some authors that publish books on Amazon sometimes will be willing to give out the book for free, or if you're at as a digital copy for free, or if you're at a university, they probably have it in your university library or a library near you that you can probably just go into, get a library card or something, and like borrow the book for a bit. It's only about 200 pages, so it will take you like maybe a week or two to read through, but I do genuinely recommend it. I think it looks pretty good. Anyway, I'm shilling it enough that I also recommended it to my brother. It does cover some like Java specific stuff, but that's only in the examples, and it has like C examples, C++ examples as well. But I do genuinely recommend it. I think the book is pretty good, and I believe most programmers, if any programmers, should read it just to like just as like a thing for like best practices. Yeah, just as like a guide, not like a guide, but just like a reference for what best practices should be like. Like some things you just won't be able to do, right? And like some things in that book are like, of course, if you could, you would just want to do it that way, right? But if you can't do it that way, you can get as close to as possible, just because it makes your life as a developer easier that way. It might be a lot of upfront work now, but in the future, it will make your life a lot easier. And I like that. I like thinking that future me will have less of a hard time doing something than current me, because I'm putting up all of this upfront work to get that work in, if that makes sense. Like, it's still gonna be a ton of things that you need to change or fix, or like some random thing that there's a span in the works, right? But as long as you're putting in all that upfront effort to make it easier for you in the future, that's a lot more fun. Well, I find it a lot more fun refactoring and like trying to work things in and like trying to think about, oh, is this the best way to do this? Is this the best way to do that? That's a lot more fun to me than just, let's just change one line and see, and right? But that's why I'm saying that, just think about reading that book and just think about, okay, in some of your like side projects that you currently have, or some projects that you've done at university, what could you have done differently that would have made that, if you were to use it in the future, would help future you have an easier time modifying it, adding stuff to it, or changing things, right? Like, that's a lot nicer. That's why you'll see lots of design patterns, like, or software design architectures like MVC, Block, SPOM. For people that don't know what SPOM are, it's screens, providers, assets, utilities, widgets, models, and services. There's also MVVM, which is mainly for like mobile apps. What else? I'm trying to think of another one. There's another one that I'm thinking of, but I can't think of it right now. But those design languages are basically like, segment your application so that if you need to add new logic or modify logic, it's a lot easier, right? Well, this is the same thing, but instead of just, separate things out into different folders or like packages or modules, think about actually like when you're developing, what would be the easiest thing for you to do that will make it easier for you in the future if you were to modify this class, change or add something to this class. Anyway. Nice. Anyway. Oh. There we go. Chapter 18 is particle effects. There we are. Anyway, thanks for watching. Like, subscribe, enjoy the rest of your day, and peace.